Wheels are a great invention. They help us humans to explore our planet Earth. Now we are taking wheels to the red planet. We are in Zurich, Switzerland on a space mission. This cosmopolitan city is not only a center for global banking, it's also a hub for innovation, and here we are going to see the ExoMars locomotion tests. These wheels are designed for flat surfaces, but what will happen if I encounter an obstacle like this one on Mars? So another challenge for the rover will be to overcome slopes like this one or even steeper. And clearly these wheels are not made for walking on a sandy area. So we are now in the testing facilities that will take us one step closer to roving on Mars. This is a very special sandbox. It can be tilted up to 30 degrees to simulate the angle of the slopes. I'm standing on top of 20 tons of sand. This is not any sand. It's a sand that simulates the sand that the rover might encounter on Mars.
This model has been built to simulate the flight rover, but in Earth gravity, and it maintains all the exact functional performances that the flight rover will have.
We are working here under Earth gravity, which is 3 times approximately the gravity of Mars.
We have placed on the top heavy electronics in order to be able to raise the center of mass to the one that will be on the actual flight rover and compensate for the heavy locomotion subsystem on Earth gravity.
So we will test it to run over obstacles, to run over stones, to run in inclinations on different soils, so from very loose soil to very hard soil. And we will test also things that we know that will happen, so the landing, the deployment and the egress on Mars.
Есть свои особенности в этой отработке. Большие углы схода, различные наклоны поверхности после посадки ровера могут быть, различные коэффициенты трения могут быть на трапах, поэтому достаточно сложный процесс отработки.
On every leg we have a drive actuator, a steering actuator and a deployment actuator over here. This means that we can do very accurate maneuvers because we can steer and drive all the wheels simultaneously. Flexible wheels can deform under the weight of the rover, allowing a higher contact patch, which actually means that the effective radius is of a larger wheel.
It's very nice to have the locomotion system here and to see what it can do, how it behaves, and to see actually how it will look on Mars.